Okay, linear programming. This is part 2 of this slideshow that we started the other day. So I'm going to jump down here where we left off in the first video, right here. And this is a linear programming word problem. We're going to kind of put all that stuff together we talked about in the last video. So here is our scenario or word problem. Baking a tray of corn muffins takes 4 cups of milk and 3 cups of wheat flour. Baking a tray of bran muffin takes 2 cups of milk and 3 cups of wheat flour. A baker has 16 cups of milk and 15 cups of wheat flour. He makes $3 profit per tray of corn muffins and $2 of profit per tray of bran muffins. How many trays of each type of muffin should the baker make to maximize his profit? And that right there is the point of linear programming, is this maximizing profit. I want to be able to write some constraints or some inequality equations to help me decide what is going to be what's going to help me make the maximum profit or the most profit. Now, this is a lot of information, and so we need some kind of a chart. So I made a chart here. Corn muffin trays is going to be my X value, and bran muffin trays is going to be my Y value. We have milk, we have flour, and we have the profit. So those are all of the things that were in the word problem up above. And then, of course, total. So milk. To make corn muffins, I need... Let's go back up here. Baking a tray of corn muffins takes 4 cups of milk. So 4 cups of milk, and that's per tray. And X represents the number of trays, so I'm going to have to put 4X. Okay? Bran muffins. Oh, no, let's stick with corn muffins. So then milk, or 4 cups of milk, and 3 cups of wheat flour. So it takes 3 cups of wheat flour, and that's per tray again. So I have to multiply it by that X. Then bran muffins. Baking a tray of bran muffin takes 2 cups of milk times the trays and 3 cups of flour. Right? Then it says that he has a total of 16 cups of milk. 16 cups of milk, and he has 15 cups of flour. So now that takes care of my ingredients. These two are going to be used for our constraints. Now the profit is actually, this is what we're going to use to write our objective function. And remember, the objective function is the one that we plug in the vertices or the vertices into in order to find the maximum and minimum. But we have to write an objective function. So the profit, well, he makes $3 profit for corn muffin trays. So 3 times X, because X is the number of trays. And he makes $2 of profit for the bran muffin trays. So 2 times Y. Now, it doesn't tell me how much he made total, because that's what I'm wanting to figure out, is how much profit I can make. So I'm actually going to just add these two things here together. 3x plus 2y. And that's where I'm going to get my objective function from. So my objective function is going to be profit equals 3x plus 2y. Now notice that in the objective function you have an x and you have a y and you also have that p. So I can't really graph this because I have 3 variables and I don't know what to do with that. So if you're not sure about whether it's the objective function or one of your constraints, if it has 3 variables, that ought to tell you right there that it's your objective function. You can't graph it. Okay, so here this is all nice and pretty and typed out. The objective function, I need to write the equations for the milk. So we're going to write it again straight from our tray, but this one does have, or from our table, this one does have a total, but this isn't the total amount of milk that I have. So I can't make this any bigger than 16 because, I don't have that much milk. I could use less than 16 or I could use 16, but I can't use any more than that. And then this one is the same way. I can't use any more than that. So my two equations are going to be 4x for milk, 4x plus 2y is less than or equal to 16. And the flour then is 3x plus 3y is less than or equal to 15. Now, there are two more constraints that are kind of hidden. Remember, we had talked about how sometimes there's kind of implied constraints that apply to the word problem depending on the word problem. So, what do you know about milk and flour? Can they be negative? Can I have a negative amount of flour? No. So I know that x has to be greater than or equal to 0, and y also has to be greater than or equal to 0, because that's the corn muffins and the bran muffins, and all of this that we're talking about has to be positive. So I'm going to have those two constraints there as well. All right, so here are our 4 equations, and we are going to graph them. So y equals 0 would be on our x-axis, and y is greater than that, so I'm going to shade up this way, and I'm just going to shade over here because I don't want to mess up my area just yet. And then x equals 0, or is greater than 0, and it's going to be over here, so I know that it's in this quadrant here. So let's do the other 2 equations and see where that gets us, and then we can draw our shape. So if I want to do this one by intercepts, so if I put 0 in for x, y is going to be 8. And if I put 0 in for 2, or y, x is going to be 4. So 0, 8, and 4, 0. Okay? And then if I put 0, 0 in, 0 is less than 16. That is true. And of course, this is already going to be bound by my y is equal to 0 or greater than 0, and x is greater than 0. So I know it's not going to go any farther than that. Okay, let's do the other one. 0 in for x gives me a 5. And if I put 0 in for y, I get 5 as well. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Draw this straight. Okay, so it looks like my vertexes of my shape are going to be right there, and this is going to be my shape, or my feasible region. Okay? All right. Okay, so I didn't use a ruler, so mine's not perfect. But when you do yours, you do need to make sure you use a ruler and that you are really getting those exactly right, or you're not going to get your vertexes quite right. So I think that this one here is a little low. So I did this one here all nice and straight and pretty. So there's our feasible region, and here are my 4 vertexes. Now, I still have to answer the question, which is, what's his maximum profit? Well, let's go back to the question. How many trays of each type should he make to maximize his profit? So I'm looking for my maximum. So I'm going to take my 4 vertices and I'm going to plug them into my objective function. Okay. So my objective function is the p equals 3x plus 2y. So if I do 0, well, I'm pretty sure it's not going to be 0, 0. Because if I sell no muffins and no corn muffins or bran muffins, I'm not going to make any money. So I'm going to try 3, 2. 3 plus 2 times 2. This gives me a profit of 9 plus 4, so 13. Okay, so now we have to do all three of them though, because I can't make a comparison to decide which is better if I don't put them all in. Okay, so this one's going to be 10, and then the other one is 0 in for that, is 12. So it does look like the 3, 2 is going to be our best one. So the answer is 3, 2. Now, I need to be able to interpret this as well. I'm not going to sell 3, 2 or a point, but remember, X represents the corn muffins, and Y represents the bran muffins. So what I need to do is sell, well, I didn't get this menu off of here. There we go. The baker needs to make 3 trays of corn muffins and 2 trays of bran muffins. And that is a linear programming problem, and we will be practicing some more of these. So this is just the only one for you to watch today. Thanks.